Hi there, and welcome to day 3 with Mrs. Nelson. Today's lesson is going to be on the heartbeat and the cardiac cycle. So if you want to flip to page 14 in your green booklet, that's where these notes start. I do encourage you to keep practicing those parts of the heart that we did yesterday, kind of keep reviewing. I'm trying to figure out how I can get an exit slip onto Teams and that forms that I can mark, so you can watch for that coming up, because those parts of the heart, you really can't do the heartbeat without it. So when we're looking at the heartbeat, the blood flow sequence we just looked at doesn't actually happen in a nice linear sequence. So the blood doesn't come in from the vena cava into the right atrium, past that tricuspid valve into the right ventricle, out the pulmonary artery, past that pulmonary semilunar valve to the lungs, back via the pulmonary vein into the left atria, past the bicuspid or mitral valve, into the left ventricle, and then out to the aorta past that aortic semilunar valve. Instead, the two atria contract, pushing the blood into the ventricles. So the top of the heart kind of squeezes and forces the blood from the two atria into the ventricles. Then, once that happens, the two ventricles contract, and that pushes the blood out of the heart into those arteries. So the right ventricle would push it into the pulmonary artery, and the left ventricle would push it into the aorta. If you've ever heard someone's heartbeat that you hear, that lubbed up sound, can be divided into two phases. So the first phase, the atria contract, while the ventricles are relaxed. So in that phase 1, there's high pressure in the atria and low pressure in the ventricles. Phase 2, the ventricles contract while the atria are relaxed. The high pressure in the ventricles, low pressure in the atria. And that lub-dub sound you actually hear is actually those valves closing to prevent backflow from one chamber to the next. So the lub would be those atrioventricular valves closing to prevent backflow when the ventricles squeeze, and the dub sound is the semilunar valves closing. So systole refers to the contraction of the heart muscle, and diastole refers to the relaxation of the heart muscle. So you can remember systole as contraction because systole is kind of the same, or sounds the same as squeeze. So I'm just going to find my pen here. So I'm still practicing on the writing. It's very awkward, so I apologize for my printing. Systole is squeeze. It squeezes during systole. And diastole is that relaxation. So we're going to do tomorrow or in a couple of days. I can't remember if it's tomorrow or not. Nope. Friday's lesson is going to be on blood pressure. But if you've ever had your blood pressure taken, you're looking for a blood pressure of 120/80. And the top number, that 120, that is the pressure on your artery walls when your heart is contracting, when it's in systole. And the bottom number, that's the pressure when it's relaxing. So if you've ever had your blood pressure taken and somebody said it was 120/80, this is measured in millimeters of mercury. The top number is when your heart's contracting, and that bottom number is when it's relaxing. So the cardiac cycle is what we would call one heartbeat. So you have about 70 heartbeats per minute. So a cardiac cycle, this occurs about 70 times per minute, and each heartbeat lasts a little less than a second, 0.85 of a second. So your heart's going to beat 100,000 times in a day in the average adult, and each heartbeat can be divided up as follows. So the first kind of 15 seconds, the atria are in systole. Remember, that's contracting. And the ventricles are relaxed. At 0.3 or 0.30 of a second, your atria are in diastole, relaxing, and your ventricles are contracting. And then fraction of a second after that, they're both relaxing. So your heart can keep a steady beat on its own. So your heart has its own electrical impulse, but how fast it goes, your heart rate, is under the control of the nervous system. So you have a heart rate center in your brain. It's called the medulla oblongata. And the medulla oblongata is basically at the top of your spinal cord, kind of your brain stem, where And this is where kind of all your life functions are controlled from. So we're going to talk a little bit more about the medulla oblongata as we go on and get into the nervous system later in the course. So your heart keeps a steady beat on its own. It has its own pacemaker, which we'll talk about in a second. But how fast or slow your heart beats is under control of that nervous system. So your medulla oblongata, that center in your brain, can increase or decrease your heart rate according to different stimuli. So the contraction of heart muscle is initiated by a mass of specialized cells called the sinoatrial node, or called the SA node. It's located in the wall of the right atrium, and it's also called the pacemaker node. I do want you to try to remember SA node or sinoatrial node, but that pacemaker node produces the electrical impulse that starts each heartbeat. So as the SA node fires, okay, it spreads quickly across both atria, so that causes the atria to contract, and then the impulse reaches that second node of tissue called the atrioventricular node, or AV node, and that's located in that septum, which is the wall that divides the left and right side of the heart between the ventricles down near the bottom of the atria. Nerve impulses are sent down from the AV node through a bundle of nerve fibers through the septum and around the base. So if we were to look at your heart, oh goodness, let's do it in red here. And if these are your 4 chambers, you've got your right atria, right ventricle, left atria, left ventricle. Your first node is somewhere up here. That's your SA node. That's the pacemaker node. It sends an electrical impulse out, and that causes the atria to contract. As that goes out, it sends a second down to the AV node, and that sends an impulse out almost up and around the bottom and causes those ventricles to contract as well. So again, here's a better picture of those nodes. So this is the SA node. Again, it sends a message out that causes the atria to contract, and it'll hit that AV node, which is somewhere down in the septum, and it sends these electrical messages down through these Purkinje fibers, Purkinje fibers. That's going to cause the bottom of the ventricles to contract and kind of squeeze the blood up and out. You watched a video yesterday, a crash course video, a little bit on the heart. It should have gone through a little bit more of this. Hopefully you find that helpful. The last piece of the puzzle, and you may have heard of this if you watch kind of medical shows on TV, or maybe you've even had someone or know someone that has, is an ECG or an EKG. So this is called an electrocardiograph, and it's an instrument that measures that electrical activity in your heart. So it can detect contraction pulses that pass over the surface of the heart, and the resulting record is called an electrocardiogram. So your heartbeat has kind of several waves. Okay, so there's the P wave, and the P wave happens just prior, which means before atrial contraction. Then you've got the big, tall, kind of pointy one here. That's the QRS wave. That is right before the ventricles contract. And then you have the little T wave, which is kind of the ventricles recovering from contraction. So I'm just going to roll this down a little bit so you can see this. So here we have our P wave. That's right before the atrial contract. Then we have our QRS wave, which is right before the ventricles contract. And then you have this kind of recovery phase, which is right while the ventricles are recovering from that contraction. So that's the kind of heartbeat we want to see if you're hooked up to those heart rate machine or heartbeat machines. That's what they're measuring. The assignment for today is to do task 12. This is parts E and F on pages 22 and 23. I encourage you to kind of keep up with the assignments, and you guys have done an awesome job so far getting those exit slips in and things like that. Part E looks at the path of the blood through the heart. So basically it's asking you to order the structures on the left-hand side, and you can just either put them in correct order by the name, which I would recommend, or by the number. I think if you put them by the name, it makes more sense when you're reviewing that way rather than just the numbers. And I would encourage you to maybe start at the vena cava. So the first one would be the vena cava. Okay. F is just a picture of that electrocardiogram, and it asks you just to kind of label those different waves on it. And there are a couple more questions you can do in the kind of potpourri section of task 12. So if you're looking for something to do and you want to go back and look at kind of part D as well, you can do most of those. Again, if you have any questions, please feel free to contact me either by email or through Teams or by phone. Hope you're doing well. Take care.